Hey students, in this video we're going to cover the law of cosines. It is the remaining case of solving an oblique triangle. If you look at the two formulas we have, one of them looks a lot like the Pythagorean theorem, with this additional part where we have minus 2 times the product of two sides and the cosine of an angle. So to do the law of cosines, you have to be given three sides, which is the case of side, 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 or two sides and an angle, which is a side, angle, side. The angle has to be the included angle, meaning that the two sides that we're given make that angle. So we use the law of cosines to either find a missing angle or a missing side in a triangle. And then we use the law of sines to finish solving the triangle. In our first example, we have to find the three angles of a triangle using the SSS case. And let me just grab my calculator. So we have side A is 21. Excuse me. So side A is 21, side B is 13, and side C is 29. So when we're doing the law of sines with the side, side, side case, the first thing that we do is solve for the largest angle. In that case, that's going to be angle C. So according to our formula, we know that the cosine of angle C is equal to a squared plus b squared minus c squared divided by 2 times a times b. And if we substitute in the values that we have, that's going to be 21 squared plus 13 squared minus 29 squared divided by 2 times 13 times 21, and that's whatever it is. So we can apply an inverse trig function, so we get C is equal to cosine inverse of this value of 21 squared plus 13 squared minus 29 squared divided by 2 times 13 times 21. And there's honestly no need to simplify this value if you're putting it into a calculator. But for the sake of argument, say we did. So 21 squared plus 13 squared minus 29 squared is this value. So we're going to be doing cosine inverse of negative 231 divided by 2 times 13 times 21 is 546. So we're really doing cosine inverse of negative 231 divided by 546. Remember, cosine inverse gives you an angle between 0 and pi. So if the value is positive, it's going to be in quadrant 1. If our cosine value is negative, the value is going to be in quadrant 2. So we should get an obtuse angle from this because the cosine value being negative means that C is in quadrant 2. So if we do that, make sure your calculator is in degree mode. So cosine inverse of negative 231 divided by 546 is, I'm in radian mode myself. Excuse me. I get 115. So I get 115.02 degrees. So, but we'll just say 115 degrees. So we know angle C is 115 degrees. So now that we know an angle and the side across from the angle, we can use the law of sines. Remember, the law of sines is sine A divided by A equals sine B divided by side B equals sine C divided by side C. And again, because we're given a complete ratio in the law of sines, we can use that instead of using the law of cosines again. So we're going to use angle C and side C to solve for, I would solve for the next largest angle. So that's going to be, in this case, angle A. So we would have the sine of angle A divided by side A, which is 21, equals the sine of angle C, which is 115, divided by side C, which is 29. And so we get sine A equals 21 times the sine of 115 divided by 29. And so A equals sine inverse of 21 times the sine of 115 divided by 29. And again, it is my recommendation that you don't simplify this so you don't get rounding error. You just put that value in your calculator. So we're going to get sine inverse of 21 times the sine of 115, and then we divide by 29, and we get 41 degrees. So to the nearest degree, we get 41 degrees. So we know angle A is now 41 degrees. And so now to solve for angle B, we can just use the triangle sum theorem. The three angles of a triangle add to equal 180. So 115 plus 41 is 156. And so then we subtract that from 180, and we get that angle B has to be 24 degrees. All right, so what we did was we used the law of cosines to find the largest angle first. Then we used the law of sines to find another angle. And then we used the property that the three angles of a triangle add to equal 180 to find the last angle. Now, if we're given just the three sides of a triangle, no diagram, for instance, what we want to do is, hold on. So what we would do then is identify which side has to be the largest side, which is going to be opposite the largest angle is going to be opposite the longest side. So in this case, we know angle A is the biggest angle. So angle A is the biggest angle because A is the largest value. So we're going to set up our formula. So we're going to have the cosine for angle A is going to equal, so in this case, it's going to be B squared plus C squared minus A squared, which is minus 21 squared. And we're going to divide by 2 times 9 times 14. So A is going to equal cosine inverse of this value. And in this time, we're just going to put that value straight into the calculator. It's going to give you exactly the same thing as if you simplified it. But since calculators can do all of their work, we'll make them do all of the work. So in this case, we're going to get cosine inverse. And if you have a TI-84, you can press alpha and y equals, and you get a fraction. So cosine inverse alpha y equals, and we get 9 squared plus 14 squared minus 21 squared divided by 2 times 9 times 14. And I get 130.6 degrees. So I'm going to say that is just 131 degrees instead. We'll say, instead of equals, we'll say is approximately 131 degrees. So the measure of angle A is 131 degrees. And so now in the law of sines, we know everything that has to do with angle A. So now we can solve for maybe angle C. So the sine of 131 degrees divided by A is 21. That's going to equal the sine of C divided by 14. So we get 14 sine 131 divided by 21 is equal to sine C, and that's going to mean that sine inverse of 14 sine 131 divided by 21 equals C. So sine inverse of 14 times sine 131 divided by 21. I get 30 degrees, so 30.2. So we'll just round down. So 30 degrees is equal to angle C. So we'll say the measure of angle C. So now we know the measure of angle C is equal to 30 degrees. Cool. So now last then is to find angle B, and that's going to be pretty easy. The measure of angle B is just going to be 180 minus 131 minus 30, which would make angle B 19 degrees. All right, so that's us using side, side, side again. Solve for the largest angle first, and then solve for another angle, and then use the triangle sum theorem. For the third example, where we're using the side angle side case, so for side angle side, we're given side A, and we're given side B, and we're given the included angle of C. So if we want to, the first thing we need to do is solve for the side opposite the given angle, which is side C. So we're going to have C squared equals, so now we're going to substitute into our formula. It's going to be A squared plus B squared minus 2 times A times B times the cosine of angle C, which is 82. Now again, this is something you can put straight into the calculator. Remember, when you do a square root, you get plus or minus, but since we're dealing with the side length, we want the positive value. So we want to have the square root of 12 squared plus 13 squared minus 2 times 12 times 13 times the cosine of 82. And again, you could do all of this in the calculator in one step. And so we're going to get C equals, it's a long calculation, so 12 squared plus 13 squared minus 2 times 12 times 13 times the cosine of 82. I get C to be 16.4. So they rounded to the nearest yard. We'll go 16.4 anyway. So C is 16.4 yards. All right, so now we know that over here, C equals 16.4. And we now need to find either angle A or angle B. I say we next find angle B because B is the next largest angle. And to do that, we're going to have the sine of angle B is divided by 13 equals the sine of angle C, which is 82, divided by side C, which is 16.4. This is going to imply that B, well, we won't skip any steps. So we'll say the sine of B is equal to 13 sine 82 divided by 16.4. And so B is equal to sine inverse of this value. So sine inverse of 13 sine 82 divided by 16.4. And that is, I have no idea. So sine inverse 13 sine 82 divided by 16.4. And that is going to give us 51.7 degrees. We'll knock that up to, so let me make sure, 13 sine 82 divided by 16.4. I get 51.7 degrees. Yep. So we'll say that's 52 degrees. So now angle B is 52 degrees. We'll put the measure of angle B is equal to 52 degrees. And so now that just leaves us to find angle A. And again, that's a pretty easy calculation once you know two angles in a triangle. So the measure of angle A is 180 minus 82 plus 52. That's 134. So angle A is going to be 180 minus 134, which is 46 degrees. And all of the things that we know from geometry are still true. the biggest angle is opposite the longest side. The shortest side is opposite the smallest angle. And that's true for the information that we found here. So again, what we did in this case was we first solved for the angle opposite solve for the side opposite the given angle. Then we used the law of sines to find one of our missing angles. And then we used the triangle sum theorem to find the other missing angle. All right, so that's the side angle side case when we're given a diagram. And the last thing that we're going to do is, I'm pretty sure this is going to produce the ambiguous case of the law of sines. So let's see what happens. For example, we're given, let me move this out of the way. All right, come on. So we're given B is 10, C is 14, and A is 27. So in some way, we're given, if we draw, I don't want to draw the triangle because it's not going to be an exact thing. So we're going to have this side's 10, maybe this side's 14, and we're given angle A is 27. So this angle is 27 degrees. So we're given A, if we had to like draw a triangle, for instance, then this is going to be angle B, that's going to be angle C. Now again, the triangle looks nothing like this. It's something we can, I guess, visualize. So first we need to solve for angle side A. So side A is going to be A squared is equal to B squared plus C squared minus 2 times B times C times the cosine of angle A, which is 27 degrees. And so A is going to equal the square root of, all right, I don't want to actually write all of this over. A is going to be the square root of all of what I'm circling. So A is the square root of that thing. So let's put that into a calculator. And we get the square root of 10 squared plus 14 squared minus 2 times 10 times 14 times the cosine of 27. I get 6.8. So A is equal to 6.8. So what we should do here is now find the value of the largest angle. Now, according to our diagram, so we know all of our side lengths now. We know C equals 6.8. So that means, not C, A, I'm sorry. A is 6.8. So we know that C is the largest angle. So C is the largest angle. Now, there are two ways you could do this. In this case, I would recommend using, let's see what happens if we do the law of sines. So we could also use the law of cosines because now we know 3 sides. Yeah, maybe let's go that route. So let's see, we'll say cosine of angle C is equal to, so it's going to be A squared, so 6.8 squared plus B squared minus C squared divided by 2 times 6.8 times 10. And that's going to give us, let's see, so cosine inverse of 6.8 squared plus 10 squared minus 14 squared divided by 2 times 6.8 times 10. Hold on. I put something in incorrect. So cosine inverse, let me put in a fraction, alpha y equals. So 6.8 squared plus 10 squared minus 14 squared divided by 2 times 6.8 times 10. I get 112. So we'll say 112 degrees. So C is 112 degrees. So of course my diagram is not accurate. The measure of angle C is 112 degrees. And what that leaves us with is only finding angle B. So the measure of angle B is going to be, let's see, 27 plus 112 is 139. So B is going to be 41 degrees. All right. So that is us solving for the largest angle using the law of cosines. So let's look at this as if we had done the law of sines. So in this case, now we're going to get something slightly different. We're still going to use the fact that A is 6.8, but I want to show you why we should maybe use the law of cosines over the law of sines here. So if we did the law of sines, what's going to happen is that we would get the sine of C divided by 14 equals, all right, so we know A, right? So we're going to say the sine of 27 divided by 6.8. We get, let's skip ahead a step. So C equals sine inverse of 14 sine 27 divided by 6.8. And remember, sine is positive in two quadrants. So it's positive in quadrant 1 and quadrant 2. So what we're going to get is C equals sine inverse of, let's see, 14 sine 27 divided by 6.8. That is 69.1 degrees. So we'll say that's basically equal to 69 degrees. Now the problem is that according to our diagram, according to what we know with A being 6.8, B being 10, and C equals 14, is that C should be the largest. So if C equals 69 degrees and A equals 27 degrees, that means that B, I'm sorry, I should make a capital A to avoid confusion. So that means that B is 180 minus 69 plus 27, which is, that's what, 96. So then 180 minus 96 means that angle B has to be 84 degrees. That violates the fact that B should be smaller than angle C. So what that means is that we should not use this 69 degree angle. Instead, we want, C is 180 minus 69 degrees, which is 111 degrees. Because again, sine's positive in quadrant 1 and 2. So there's an angle in quadrant 1 that has that sine value. There's an angle in quadrant 2. This is our reference angle. So the angle that we want is this angle. We'll draw a double arc, I guess. So this is the angle C that we want, the one that's in quadrant 2. So if we do the law of cosines to find our angle once we have our three sides, that's going to always give you the largest angle instead of having to worry about using the law of sines and you get two possible answers. So after you find the longest side, to find the third side, use the law of cosines to find that biggest angle.